All right, here we go. We got systems of linear and quadratic equations. So the first thing we are going to do here, first thing it says there is how do you solve systems of linear equations? When we did this with substitution, elimination, and then also graphing. Those are kind of the main ways. I guess you could also say matrices here, but that's not going to apply for today. So we can do the same exact thing with x squared graphs or quadratic graphs in linear equations. So we're going to draw some examples of what the intersections might look like. So here would be like a typical quadratic equation, and then here would be like a y equals mx plus b line, and this would have two different solutions right here in that case, as far as where they intersect. Now you can do another example here where it only intersects a graph once, and maybe that's where it just barely touches your graph and it only touches once right there. So this would be one solution. And then you can also do an example where your quadratic never actually touches your line right here. And if they never touch, we would say no solution in this case. That's kind of what I guess all the different cases could look like. So we're going to talk about solving those today. The first way will be with graphing. All right, most of the times we'll have a graphing calculator, so we'll go ahead and type this stuff into your graphing calculator. So I actually have already done that a little bit here, so I'm going to pull that up here. So remember to go to graph something, hit y equals, type in everything. If your graph is kind of messed up, you can reset the zoom, or if you hit second plus 712, that will reset all the stuff that you had in your graphing calculator. And then to graph it, we'll hit graph, see what that looks like. And those are your two graphs. Now, as far as how many solutions, it looks like it crosses twice here. It looks like over here at -3, and then this might be -2, 1, but sometimes they won't be nice points. So to go and figure out for sure where they intersect, we can hit second trace, and then we're going to scroll down here to intersect. And now, since there are two intersections, your calculator is going to find the intersection closest to your little blinky guy here. So what I'm going to do is move the little blinky guy to the left of the leftmost intersection. So if I go over there, it's definitely going to give me this first intersection and not the second one. So make sure it's a little bit to the left. Hit enter, enter, and then enter one more time. And that apparently crosses at -3, 0. And then go ahead and write that down in your notes there. And I'll switch back over here in just a second. All right, to find the other intersection, hit second trace, go to intersect, and then now move the little blinky guy, move it to the right intersections of the two, and I usually like to go to the right of those so it doesn't accidentally pick up this one over here more to the left. So this hopefully should get us this one over here by -2, 1, and hopefully that's what it is. Yep, okay, so that second intersection, -2, 1. Those are your two intersection points. Okay, now to graph something here, we need to actually go and copy down some table values. So yes, we need the x-intercepts, but also we need to show it with our graphing calculator. So we're going to hit, whoops, I guess we already graphed it. We're going to hit second graph here to go get some table values here. And just all the y's here for the blue one is for your quadratic. So we'll copy down some of those, and then we'll copy down the red ones as well. So let's do that here. We have, I guess, what was it? -5, 4. That's over here to the left. -4, 1, 3, 0. -2, 1, and then back up there to -1, 4. Go ahead and plot those points there. And usually our teachers are looking for these bullet points, so make sure you make those big enough right there. All right, as far as graphing y equals x plus 3, we can actually graph that pretty easy because we know the slope and we know the y-intercept. We know it needs to start at 3, and we can go and graph the slope from there. And then those would be your two lines right there, and then that's pretty much how you do that right there. And then notice those two intersections here, they have those two common points. So those are your solutions right there. Now, as far as steps in the calculators, I would say, type into y1 and then y2, and then we hit graph, and we hit second trace intersect, and then find both of your intersections from there, and then I guess just plot some points. And there you go, and that's how you solve a system of quadratic equations by graphing. Just look for where they intersect, use your calculator to graph if available. Okay, with this next one here, we are going to focus on solving using substitution. So the first thing here we're going to do here is substitute. Since this equation is equal to y, you have x plus y is equal to y, you're going to substitute that into this other side. So we're going to go x plus 5 equals negative x squared minus 3x and then plus 10. Now the next main thing here you want to do is get everything equal to 0. So you want to move everything to one side of the equation. So I'm going to go and do subtract x from both sides and subtract 5. That'll get us negative x squared minus 4x and then plus 5. Now with factoring, if I want to solve the rest of this with factoring, our lives are easier if we change the signs and make sure x squared is going to be positive. So I'm going to divide both sides by negative 1. And I'll just make x squared plus 4x minus 5. And that'll make it to where we can factor. And over on the left-hand side, 0 divided by negative 1 stays 0. Okay, next from here, we're going to factor x squared plus 4x minus 5. We've been doing that for a while, so if you need factor in practice, go back a couple lessons. We need something that multiplies to negative 5 and adds a 4. And those two numbers are going to be x plus 5 and x, I guess, minus 1 right there. Okay. From there, we split apart our factors. We say x plus 5 is equal to 0 and x minus 1 is equal to 0. A lot of you guys are getting to where you skip that step and you just write x equals negative 5 and then x equals positive 1 right there. And those are going to be parts of our two solutions. Now, if you go back to the graph that we just did here, usually our solutions have two pieces here. Usually it has an x and a y. This time, though, we got two x's. So what we need to go back and do is take both of these x values, plug them both back in, and figure out what y values correspond to both of those. So what makes this different as opposed to systems of linear equations with just regular lines, usually you only had one point where they crossed. Here you're going to have two different x values where they cross, therefore getting you two different y values where they cross. We're going to plug them in, I guess, one at a time here. So if I go plug in negative 5 into that second equation, that'll be negative 5 and then plus 0, or I guess plus 5. That'll equal us to 0. So writing that order pair together is going to be negative 5, comma 0. Now if we do this next one here, if we go plug in, I guess, 1 back into this equation up here, that's going to be y equals 1 plus 5. So obviously that is 6. So then we will write that as 1 comma 6, and that is your second solution point. Right there. So we'll go back here and fill in a few steps. So the first thing I would do is solve an equation. It's not wanting to work with me here. Yep, there we go. Solve an equation. Most of the times it'll be easiest to solve for y. Then after that, I want you to do the substitution. Alright, solve for x afterwards. Most of the times you'll do with factoring, but you can also use the quadratic formula. You could actually use complete the square, or you can even look for your x-intercepts or your x-intercepts on a graph. So, alright, and then once you find your x values, plug x values. And sometimes there will be multiple x's, sometimes there will only be one, so plug x values and then solve for y values. Okay, and that's a good kind of comprehensive list of solving systems of quadratic equations with linear equations. Now sometimes you will have examples where you can solve a quadratic with another quadratic. Notice you have two x squared graphs. And most of the stuff is not going to be different here. Notice they're both equal to y. So you're going to take one of the equations and set it equal to the other one. We'll get x squared plus 5 and then equals x squared minus 4x, I guess, plus 5. So there's your substitution step. You want to set everything. Usually you want it equal to 0. So we're going to add x squared to the other side. Remember, x squared is usually a lot nicer to us if we get the x squared to be positive. So I get a positive 2x squared, I guess, and then minus 4x. And everything else should cancel. Actually, the 5's cancel on the right side, so that's kind of nice. And then I guess equals 0. From here, we can factor, and this uses the factoring technique of just the greatest common factor. We can factor out a 2x or undistribute a 2x, and then you would be left with x minus 2. Okay, from there, then we can split this up. We can say our two different factors, 2x equals 0 or x minus 2 equals 0. Therefore, x equals 0 and x equals 2. So we're assuming you're real comfortable with your, I guess, you're solving your quadratics and everything. So now we need to go find the corresponding y values for both of those there. So as far as which equation is easier, I kind of like the second one here, but it doesn't matter which one you plug into. So I'll plug in 0 first here. So we got 0 squared and then times a negative. So that'll just be 0 and then plus 5. So that comes out to, I guess, positive 5 here. So one of our solutions is 0, 5. Now to go find your second solution here, we need to go take 2 and then we're going to plug that in. And I would do the easiest equation again, so I'll do that negative and then x squared and then plus 5. Now the only thing you got to be kind of careful here, this notation says to make your 2 squared first and then make it negative, so that actually comes out to negative 4. And then if we go and do negative 4 plus 5, that'll be positive 1 right there for your y value. So when we plugged in 2, we got 1 right there. And those are going to be your two solutions. And that is it there. So it's a lot of similar stuff. It's basically combining everything we know with system of equations and then combining it what we know with solving x squared type of graphs or solving quadratics. So that is that there. I guess we got a couple more here. So use graphing on this one here. So I guess we'll go back to our graphing calculator. We'll clear this out here. Apparently we got x squared. Oh, and actually I think this is actually the same exact equation here. So we're just going to go and look and make sure everything looks the exact same. So minus 4x plus 5. And this other one was negative x squared. And then I guess plus 5. And then if we have a graph, I guess we'll see what those look like. So yeah, there you go. There's your two quadratic graphs here. And then I guess I'm going to hit second graph so I can get a couple of table points here. And I'm going to copy over some of those. So let's do that. Alright, so negative 5. I'm trying to find some nice points to graph here. It looks like the first nice one here for the blue is going to be 0, 5. And we come down to 2, 1. Oh, I'm sorry, what is that? 1, 2. Select a moment there. 2, 1. Actually, 2, 1 wasn't 1. And you can go get the rest of your points, kind of like that right there. Okay. Well, try to make it kind of curved looking. All right, the next one, you had a few points. So I'm looking here in the red column. Looks like you got negative 2, positive 1. So kind of like that right there. We had negative 1, 4. Kind of like that. We had 0, 5 for both of them. And then 1, 4, and then coming back down, you got that other point right there. And then those would be your two solutions right there. You just circle those and then say, okay, and these cross at 0, 5. and they also crossed at 2 comma 1. Those are your two solutions. So you can do it both ways there, and I believe the way that the tests are worded, usually it'll say, solve using substitution or solve using graphing. So guess we got a couple more here, and then a word problem down there at the bottom here. So what is the solution to this set of equations right here? Notice they're both equal to y, so we can just plug right in right away. I guess we don't do too many examples where they're not already equal to y. So we'll do that, plus 5, and then equals, I guess, x cubed minus 3x minus 3. And then we will get all of our x's to the same side here. I guess we'll add 2x squared. We'll subtract the x, or I'm sorry, I guess we need to add x. And then we'll minus 5. Everything on this left-hand side will cancel out. You don't have to do it all in one step there. That's just something I kind of choose to do, I guess. So that'll combine up to 3x squared. I guess minus 2x, and then minus 8 right there. All right, so now we need to solve this by, I guess, factoring. And this is one of the ones where a is not 1. So we have to use one of our other techniques. I do divide and slide. Different teachers do different ways here. So if your teacher teaches a different way, just kind of bear with me here on the factoring. But we want to solve by factoring. So figure out numbers that multiply to negative 24 that add up to this negative 2. So I think we could go negative 6 and positive 4. And then we write it as x minus 6, x plus 4. And then we do divide and slide. Divide both of these here by 3. The first one reduces to 2. The second one doesn't reduce, so you slide the 3 out in front, and that's 3x plus 4. And if you're like, where the heck did that come from? Once again, go back and catch up on your factoring lesson. I think that was 5, 6, and 5, 5 were factoring. Okay, and then from here, split your factors up and set them equal to 0. X minus 2 equals 0, so x equals 2. This other one, 3x plus 4 equals 0, so 3x equals negative 4. And then, once you divide, that'll get you x equals negative 4 over 3. Okay, and then we, I guess we go and take those values now and then go plug them back in to your equations here. As far as which one is easiest, I guess neither of them are that great. So I guess I'm going to choose the first one here. So I guess I'll do 2. Let's start out with the whole number. We'll do 2 in blue right here. So that'd be 2 squared minus 3 times 2, and then minus 3. So that'll be 4 minus 6, and then minus 3 right there. So what's that? Negative 2 minus 3. I think that comes out to negative 5. So one of our solutions was 2 comma negative 5. Okay, so now we're going to go plug in 4/3 right there, or negative 4/3. So when we plug it into the first one, it's not going to come out the best, but we'll get through it here. So negative 4/3 squared minus 3 times negative 4/3. And then I guess, what was it, minus 3 here at the end. And when you're squaring a fraction, just square the top and square the bottom. That'll be 16 over 9. Negative 3 times negative 4 would be positive, I guess, 12 over 3. And then after that, we're going to do minus 3. And I'm going to write that as a fraction. I'm going to write it as 3 over 1. Now, to add or subtract fractions, we're going to use common denominators, kind of like what we did in middle school. So I'll multiply the top and bottoms here by 3. And then for the second fraction, I need to multiply top and bottom by 9. So I'll give me 16 over 9, I guess, plus 36 over 9, and then minus 27 over 9. Not the nicest looking thing here in the world, but once you combine your fractions up, that'll come out to 25 over 9 once you do all that there. You basically add up all your numerators together. That'll get us 25 over 9. So the answer to this one here will be negative 4/3, comma 25 over 9. And that'll be your answer there. Okay. From here, let's see, what do we got? This last one here, the coordinate plane, when x is between -5 and 5 and y is between -5 and 5, models a square reflecting pool. The path of the remote control boat on the pool is modeled by this equation right here. The path of a second remote control boat is a straight line through these 2 points here, -2, 1, and 3, -4. Find all the points for which the two boats may collide. So I guess here on this one, they didn't give us an equation, so we're going to have to think back to a little bit of Algebra 1 stuff. In Algebra 1, you guys would find the slope between 2 points, so we're going to do that using y2 minus y1, so -4 minus 1, and then 3 minus -2. Okay, so that'll come out to -5 in the numerator and then +5 in the denominator, so that'll come out to -1. Okay, after that, y'all usually chose 1 point and you used this thing called point slope formula. That was y minus y1 equals m, and then x minus x1. And then we can go and plug in everything. Y minus 1, -1 for the slope, and then x minus -2, so x plus 2. Then we can distribute, and then we can add the 1 to the other side, which will get us, I guess, -1. Okay, and that would be your equation of a line right here. So that's the first thing you need to do there, is find the equation of a line. So that's quickly recapping all that. Then since that is equal to y, and this equation is equal to y, we're going to set these two equations equal to each other. I'm going to say -x, I guess -1, equals x squared plus 2x minus 1. Okay, from here, we're going to add x to both sides because we want to cancel out. And we'll add 1, which will also cancel out the 1's on the right-hand side. That gets us 0 equals x squared plus 3x. Now, from here, we will factor out x, write this as x plus 3, and then split your factors apart and say x equals 0 and x plus 3 equals 0. And then subtract over x, equals -3 as one of your answers. And then x equals 0. So then after this, now we need to go take those x values and then go plug them back in to figure out what your y values are going to be. So I'll do that at first one there, 0 minus 1 basically. So that comes out as -1. So that point will be at 0, -1. And now let's go plug in -3. So that'll be -3, which would be +3, and then -1. So that'll come out to 2. So that'll be the order pair -3, 2. Those would be your two solutions there. And so I guess that's where the two boats would collide. I believe that is it.